What is vacuum impregnation? Vacuum impregnation is a method to get rid of porosity in different components, including metal casting parts. It is also called porosity sealing or porous metal sealing. The metal impregnation technique was first introduced in 1940, and the method has been improving since then. The vacuum or metal impregnation technique can seal both micro and macro porosity, but it doesn't change the functional or mechanical properties of a part. The four main steps for this process are as follows. Step 1. At first, a vacuum is created inside the impregnation chamber where the metal part is placed for impregnation. The vacuum clears the air out of the leak path. Step 2. Then, a sealant covers the whole part, and pressure is applied so that the sealant can fill the porosities. Step 3. After that, the casting part enters a rinse or wash station. Here, the residual sealant is extracted from the pockets, internal passages, or taps of the part, because here the sealant is undesirable. Step 4. Finally, the die casting product goes into a cure station where the impregnated sealant in the path of the leak is polymerized. Benefits of vacuum impregnation. A casting part can have a lot of benefits from it, such as it can save a part from degradation and also from cracking. Porous metal sealing helps to eliminate leaks in metal casting parts. Aluminum die casting impregnation extends the overall life of a metal part. Porosity sealing helps to reduce scraps as well as wastes in production. It saves the overall cost of production because it fixes the ruined parts. What are the methods of vacuum impregnation? Die cast manufacturers use the following methods for vacuum impregnation. Dry vacuum and pressure impregnation. Here, manufacturers clear out the air in the impregnation chamber after placing the casting part. Then they take the sealant into a pressure vessel. From there, they apply pressure to the sealant so that it can penetrate the pores in the part. Wet vacuum impregnation. In this method, manufacturers take both the sealant and the casting part inside a vacuum chamber. After clearing the air in the chamber, they immerse the part into the sealant. When the sealant fills all the pores, the part becomes ready for rinsing. Wet vacuum and pressure impregnation. This method is similar to the previous one, but there is a small difference. In the wet vacuum method, there is no external pressure necessary, but in this method, external pressure helps the sealant to fill all the pores. Internal impregnation. The casting part itself acts as the vessel for the sealant in this method. At first, manufacturers put the part in a vacuum chamber. Then they fill the part with sealant and wait for it to reach all the leak paths or pores. Finally, they take out the part for washing or rinsing. What are the components of vacuum impregnation system? Vacuum impregnation systems are of two types, such as automatic and manual. Robotic mechanisms control the automatic system, whereas workers control the manual system. However, both systems have some common components such as pressure or vacuum autoclave, centrifuge or drainer unit, rinsing and washing station, curing station. Despite having these common components, the cycle time of the manual system is longer than the automatic system. Moreover, the automatic system is more precise than the manual system. But in the case of different metals, such as aluminum die-cast impregnation solutions, both systems are applicable. What type of porosity can vacuum impregnation seal? In die casting parts, porosities are of three types, such as blind porosity, through porosity, fully enclosed porosity. Blind porosity is the type of porosity that has an open end on the surface of a casting part and also a closed end. On the contrary, through porosity has two open ends on the opposite surfaces of a casting part. The fully enclosed porosity has no open end because the casting part's surface fully surrounds it. When multiple pores connect with each other, the path created is called a leak path. Vacuum impregnation can seal any size of pores as well as leak paths, but to do so, the sealant has to find a way to enter the seal pore or the leak path. If the leak path or the pore has no open end, the sealant cannot enter the hole. So vacuum impregnation can seal blind and through porosities, but usually it cannot seal a fully enclosed porosity. However, if a fully enclosed porosity somehow connects with a blind or a through porosity and makes a leak path, then vacuum impregnation can seal it.